Hi everyone and welcome. Today I am going to give you a fast practical introduction to Spring Security, how it handles authorization for your Java applications. This whole walkthrough is designed to take about 5 minutes. So let's dive right in. So what exactly is Spring Security? It's a customizable framework that handles authentication and access control for Java applications. Built on Spring, we need it because every web app faces real threats, SQL injection, cross-site scripting, CSRF, broken authentication. Instead of building defenses from scratch, Spring Security gives us battle-tested protection out of the box. There are five big regions teams reach for Spring Security. It protects your REST APIs from unauthorized calls, handles user authentication, enforces authorization based on roles, manages user sessions, and blocks CSR web attacks. All of that comes ready to use. You're not reinventing any of this yourself. Let's look at how a request flows through Spring Security. It starts at the client. It's the filter chain which intercepts every request. The authentication manager coordinates the attempt and hands off to an authentication provider which validates the credentials. The user details service loads the user's data and the result lands in the security context, holding the authenticated user for the rest of the request. These two terms get mixed up a lot, so let's be clear. Authentication answers who are you? That's your login step. Authorization answers what are you allowed to access. That happens after you logged in and decides what you can actually do. Spring Security handles both but configures them a bit differently. Here's the login journey. Step by step, the user enters credentials sent as a login request. The Spring Security filter intercepts it, and the authentication manager uses the user details service to pull the matching code from the database. Match and the security context is set. No match and access is denied. These are the six building blocks you'll keep running into: security filter chain, authentication manager, authentication provider, user details service, password encoder, and security context. Once these names click, the rest of Spring Security's documentation gets a lot easier to follow. Let's talk passwords. Never store them as plain text. Spring Security go-to tool is bscript password encoder, a strong salted one-way hash. So identical passwords still produce different results, defecting rainbow table attacks. In code, create the encoder call encode method to hash before saving and later call matches method to verify a login attempt against that hash. Here's the, here's a basic setup. Spring Boot 3. You define a security filter chain being using HTTP security, authorize HTTP request, marks which URLs are public. Here anything under slash public. and everything else requires authentication from login. Enables that the default login from and CSRF turns on CSRF protection. This one bean replaces the older configuration style entirely. REST APIs are stateless, so we secure them differently. Four common approaches. JWT, a self-contained signed token basic authentication. Credentials on every request, bearer tokens in the authorization header, and auth to delegating to a to a trusted provider. In practice, the client attaches a token and the security filter validates it before reaching your resource. Beyond the core login flow, Spring Security ships with a lot more built-in CSRF and CORS protection. Fine-grained session management, remember me, for persistent logins, safe logout handling, and customizable exception handling for unauthorized or forbidden access. All of it configures through that same HTTP security builder we just saw. Before we wrap up the technical side, 6 habits worth adopting. Use strong password encoding. Follow the principle of least privilege. Enforce HTTPS everywhere. Model access with role-based control. Disable default credentials before going live and keep your dependencies updated. These alone prevent most real-world security incidents. To be balanced, Spring Security integrates easily with Spring Boot, ships secure defaults in highly flexible and scalable to enterprise needs. On the flip side, it does have a learning curve. Configuration can get complex for advanced setups and debugging. Exactly why a request got rejected takes some getting used to. Here's how it all comes together. A frontend calls a Spring Boot REST API. Spring Security validates the JWT on the request. Then does the API reach into the database? This exact pattern shows up everywhere. Banking, e-commerce, healthcare, and large enterprise systems all rely on this same layered approach. So to recap, authentication confirms who are you, authorization controls what you can access, the filter chain processes every request, password encoding protects stored credentials, and REST APIs get secured with things like JWT and OAuth2. That brings security in a nutshell. Thanks so much for watching.